Okay, why not closures? What are the alternatives to closures? What can we do in the language that is equivalent to what closures provide? Okay, so early on in the design, I assumed that I was going to add closures relatively soon, and I just have never done it because honestly, it has not been that important for what I do. Um, I understand that some people like them. I did computer science at University of California, Berkeley, where they teach how awesome closures are in the very first class. Since then, though, I got cult deprogrammed, and I don't actually think they're awesome. For many reasons, not least of which is efficiency of your program, right? For the same reasons that I talk about sometimes in lectures, also in the how-tos for the language about paradigms like object-oriented programming, or even just things like the fact that you should use smart pointers for memory allocation. The same way that those things insidiously make your program very slow and hard to understand in ways that you don't expect, closures do the same things. Because a closure is like, look, this is an instantiated thing with certain particular data that has its own lifetime separate from other data. And you honestly don't really want to do that if you can help it. It's not, it imposes a lot of costs that people don't necessarily think about. Now, that said, it is still in the roadmap probably to provide closures at some point. There are practical implementation questions of how do we provide all the flexibility that you have in the language with regard to allocators and that sort of thing, without making closures too much of a hassle. Also, how do you avoid the big annoying thing that like C++ did, right? So in C++, a closure is essentially, a functor, which is essentially a struct with an overloaded paren operator, but that means it's not actually a function type. So anytime that you want a negative function or a closure, you need a special thing. And actually, of course, because C++, like a member function is also a different type, right? So like C-style function, member function, and closure are all totally different things actually, right? And then you need to paper over that at user level. How do you avoid that? Well, I think the way to avoid it is by having all the standard function type in the language be a fat pointer, right? Where every function has a data pointer that it could refer to, right? Because, for example, when we're talking about allocators, right? You have allocator and allocator data all the time, and you need to pass those, right? Why is that? Well, you might have a lot of different heaps, right? And the allocator might be the heap handling function, which might be the same for all those heaps, but the allocator data might be the pointer to the base of the heap, which is different for all those heaps, right? So even without closures, very often you want to have a data pointer for functions. This is also true just with thread safety generally, right? So like qsort in C was like, hey, here's the type for the sort function that you pass to qsort. It takes 2 arguments and not really that much else, right? And so historically in C, if you wanted to do qsort and you needed more data, you would just put the stuff into the global data. You'd make some global variables that function reads, and put the values in there, and then run qsort on those, and it would do the thing, right? But that's very bad for thread safety, right? So now maybe you put those in thread local storage, but that has performance penalties, and also it's error prone and all these things, right? And so it's just kind of a good idea to have a data pointer with a function pointer, right? So that is probably what will happen. Of course, you still need to specify sometimes. If you want to have a function pointer that you pass into C, you have to specify that it's actually just the bare code pointer with no data pointer and so forth, right? So that's been the vague plan for a long time. It's just that some of these other things seem more important, right? Like the module features I discussed before seem a lot more important to me than adding closures. And so that is what that is. But I would expect that, first having data pointers be part of the function pointer type would happen. and then you could explicitly set those. The same way a string has like, dot data and dot count, probably a function does too. And it's probably, dot code and dot data or something, right? And then after that, so first we would implement that, see what all the ramifications are, deal with that, and then implement closures on top of that. And then the nice thing about that is once that's done, you can have all kinds of stuff, right? Like you don't have the C++ problem of a functor and a native function type being a totally different thing. They're like the same thing, right? So you don't need to make a mess everywhere like you do in C++. I'm not getting through the questions very fast, but you know what? I'm just going to go through the questions in order. And if everybody gets tired and leaves and we go way too long, we can just do another one next week or in a couple weeks. We'll see. I didn't preset a prescribed length for this session. So we'll just see how long it goes. And yeah. Okay. You often talk about how syntax is not definite right now. Is there anything that you are seriously considering changing in the future? Looking at you, AutoCast. Yeah, AutoCast maybe. It is weird. The dereferencing pointers is a little bit weird. That said, I'm thinking about looking at a little bit more implicit casting. I'm looking at adding an implicit pointer dereference. So if you have a pointer to something and you're calling a function that takes that thing by value, implicitly dereferencing that, which might sound scary because it's like, oh, I might get a null dereference in a weird place that's hard to debug. But in a debug build, you can have a compile time check for that, just like an array bounds check. And so it would be very easy to isolate where that went wrong, right? So that would result in writing dereferences explicitly less often. But yeah, like changing the dereference. But honestly, I'm not thinking that hard about that stuff yet because I really do want to do a question everything kind of syntax approach a little later on. When, like once things go in, maybe before open beta, right? Because you want to, you don't want everyone in open beta to have to like do a big syntax adaptation. But, look, we're questioning everything. We're questioning every operator, the way declarations happen, all that stuff, and just seeing, some of the syntax I think works out very well and is unlikely to change, but some of it, some of it, there are clear downsides to. So for example, the colon equals versus equals thing is an easy to make mistake. Like I've said, it's also an easy to catch mistake, hopefully. But until we actually implement that checking and see how often that mistake is caught, that assertion that it's an easy to catch mistake is untested, right? And so there might be something still not easy to catch about that, which might lean more strongly on, oh, we should change that, right? So that's the story about syntax changes. As with standard modules, could there be standard metaprogram modules which could be included to enhance build processes, for instance, to impose common house rules? Yes. And so, okay. So you already could have that right now. In fact, modules/check is one of these. So if I go there, you can just call this function. It's not documented right now, but you can call this function do error checking on a compiler message, right? And it does some stuff, right? It does 200 lines worth of stuff, including printf checking. So like printf and scanf like functions. Is that all that it does right now? That's all that it does right now. But you could add other standard checking in here, right? Or add more modules or something, right? Now, the thing that this doesn't do, this is just a function that you call, right? What if this requires some setup, right? What if it requires some shutdown, right? I don't know. And so there's a question of should we make more of a convention for that? And well, I think the answer to that is I should make it possible so that there's more of a convention, and I should maybe make one that you could start with, but I don't want to I don't want to constrain that either. Like if people decide that they have a better way to organize these, right? And so if we put up like the standard meta program, like I was saying at the beginning, the question is, would things be pluggable into that? Like, okay, oh, that's another question is, can these read command line arguments, right? I mean, they could already just of their own volition look at the command line because you have a call to like get that. But is that a good idea? Like, does the main program want to filter out arguments meant for one thing versus another thing? I don't know. All this really, I think, is to be figured out, what that structure could look like.